can have a quick revision on different methods for integration, starting with the first one, which is substitution. Then we're going to see integration by parts and also partial fraction. Integration by substitution is basically having different variable for a specific term. When we use this type of integration when we're having two functions which are multiplied together. So let me just tell you that here this is a function that we can call g of x, and here is another function which we can call f of x. So those are two functions that are multiplied together by each other, and we cannot just say that we can separate the integration or substitute the integration for each one. This cannot be happen. So we use the substitution method. Now I will tell you which term you choose to be your variable, which is u. Basically try always to take the one with the power. So as you can see here, sine 2x cubed, this one is having a power, and as the degree of the power is higher than the other term. However, also here we have which is 1, but the sine is having a higher degree. That's why we're gonna take this term as our u. So I'm gonna say that u equals sine 2x, and after just choosing the term that gonna be u, we need to find du. So the derivative for the sine is 2 cosine 2x. As you know, we take this 2 outside, multiplied by the sine, or the derivative of what is inside the sine, and the derivative for sine is cosine 2x. The angle stays the same. And now, as you can see here, I'm having 2 cosine 2x, which is similar to this one. However, I don't have the 2. So what I'm gonna do is multiply by half outside my integration, and I will add 2 cosine 2x. So when I multiplied by half outside my integration, I'm having everything as it is. So I'm not changing the values, because when I multiplied by half here, I multiplied by 2 inside the integration, so I can have this term as well. But let me first write here u power 3, and then I'm gonna write 2 cosine 2x dx. Yeah, and here also we have dx. So all of this equals du. So I'm gonna substitute by this term by du. So we're gonna have half multiply integration u power 3 du. And now it's very important to change the dx to du, because now you're saying that I'm integrating with respect of the variable u. So now the integration of any variable which is raised to a power is adding 1 to the power and then taking this power and dividing by it. So I will end up by half, and here I'm gonna say that u power 4 over 4, and then of course plus c. Also, you can just multiply the half by the u, this term only, as also if you multiply c by half, also you're gonna have another constant, which is c. So I can simply say that I have u power 4 over 8 plus c. However, I cannot stop at this point, because my variable that was in the main and original equation wasn't u, it was x, and u equals to sine 2x. So I'm gonna say that this equals to sine 2x all power 4 over 8 plus c. And by this, we solve this equation simply. So always when you have a power, think about substitution, or also we're gonna now see another example, and I'm gonna tell you why we use the substitution here. However, try to pause the video, try to think which term you're gonna take it as your u, and then after solving, just continue with us and check if you did it correct or not. However, if you didn't do it correct, it's totally fine, because this needs a lot of practice. So let's try now to solve it together. As you can see here, I'm having two terms that are divided by each other. So I'm having 6 ln x plus 5 over x plus 5 dx. So for this one, as you know, I don't have actually like an integration for ln. So what I'm gonna do is taking ln x plus 5 as my u. However, if you only took the bracket x plus 5, this won't solve the problem, and you're gonna remain with the same problem, which is integrating ln. So now the next part is finding du. So du, the derivative of u is du. And now what is the derivative of ln x plus 5? The derivative of this will be 1 over x plus 5 dx. So as you can see here, we're having something similar. So let's try to separate things to visualize more the problem. Simply, I'm going to take this 6 outside the integration, because it doesn't mean any, like there's no difference if it was inside or outside the integration, because it's only constant. So I'm going to have 6, and then integration ln x plus 5, and then here multiplied by dx over x plus 5. And as you can see, this term is just similar to this one. So I can say simply that I have 6 integration u times du. So it's so simple, this one. So now I'm going to integrate the variable u. And now, as you know, here I'm having power 1. So I'm going to add 1 to this power and divide by 2. So u power 2 over 2 plus c. And don't forget the 6 here. However, also the 6 of u multiplied by c or not, at the end we're just having a constant. And as I told you, we cannot just keep it like this u, because our main variable was x. So u actually equals ln x plus 5. But let me just simplify this. We have here 3, and this has gone. So we're gonna have 3 ln x plus 5 all power 2 plus c. And that's it for the integration using substitution. Why did I use here substitution? Because I have like a term and its derivative. So as you can see, the derivative of ln x plus 5 is 1 over x plus 5. So also whenever you have like a term and its derivative, use integration by substitution. However, also like always try to have it as a rule. Whenever you see any integration problem that you cannot just solve it easily, use integration by substitution. If it didn't work, we're going to go to the next type of integration, which is by parts. So let's see this example. Will it help me if I'm going to use integration by substitution? Like for example, if I said len x is my u. Let's just try to do this now, because I want you to know how to decide which method to use. So I'm gonna say that my u is len x. Always take the u as len x, because you cannot just integrate len x. So my du will be 1 over x dx. But is this similar to this? Like if we tried, for example, to separate them. For example, I'm having len x times x dx. No, they're not. So this won't solve the problem for me. So what I'm gonna do is integration by parts. And in integration by parts, we're having 2 variables instead of only one. So I'm gonna have u and dv. So u is just similar to what we did in the integration using substitution, and I'm gonna choose len x. However, dv means that x is the derivative, and when I need to find v, I need to find the integration of x. So the integration of x will be x power 2 over 2, and du, which is the derivative of u, which is len x, will be 1 over x. Then simply I'm gonna multiply uv. So let me just write it here. So you multiply uv by each other, and then you subtract the integration of v du. So now let's apply this rule. However, you don't need really to memorize it, because just do this. If you write it in this way, it will be easily just to do it with the arrows. So u times v, and then v times du. So let's do it now. I'm gonna have x power 2 over 2 len x minus integration of and here dx. Don't forget the dx. So here I'm gonna have x power 2 over 2 times 1 over x dx. So as you can see here, this x will go with one of those. So we're gonna have, let me just write it again, x power 2 over 2 len x minus x over 2 dx. So then I'm gonna integrate this part. So I will have x power 2 over 2 len x minus, the integration of this will be x power 2 over 4, and don't forget the c. So that's it for this problem. As you can see, we tried solving it using substitution, but it didn't work. So we went to the other one, which is by parts. It's similar to the substitution. However, we're just adding like another variable, which is dv, and doing some multiplication and things. However, it's still easy, and this simplified our problem. Let's go now to another one. So for example, this problem, try to pause the video and solve it yourself using first substitution, and then if it didn't work, go and try it by parts. This is so important, as you're gonna understand and decide when to use by parts and when to use substitution, and not just only memorization. So let's do this together. I'm having len x dx. I'm gonna try solving it using substitution. So I'm gonna have u as my len x and du as my 1 over x dx. However, I don't have 1 over x. I only have dx. So this won't work. Substitution won't work. So what I can do here? What I can do is just keeping this and having dv, 1 over x dx. So I'm gonna have u as my len x and du as my 1 over x dx. However, I don't have 1 over x. I only have dx. So this won't work. Substitution won't work. So what I can do is just keeping this and having dv, 1 over x dx. 1 over x dx. And I'm going to say that dv will equal dx. So v equals x. And we use the arrows again. So uv will be x ln x minus integration of v du, which is x dx over x. And those will go together. Then again x ln x minus integration of dx, which is x ln x minus x plus c. So we're done now by integration by parts, and moving to the next type or method for integration is partial fraction. So for the partial fraction, we use it in case if we have a polynomial divided by polynomial. So let me just tell you, if we have here two polynomials, however this polynomial is having less degree than this one. So let's say that the degree for this polynomial is m, and the degree for this polynomial is n. So n should be greater than m to use the partial fraction. So let's check our example here. As you can see, this polynomial is having a degree of 2. However, this one is 3. Why this one is 3? When you're gonna check, you're gonna say the first bracket is 1, and the second one is 1, and the third one is 1 as well. So how we're getting 3? But those are multiplied by each other. So when you multiply like two brackets together, you're gonna get x power 2, and then multiplying this with another bracket, you're gonna get x power 3. That's why the degree for this polynomial is 3. So as you can see, m is less than n, because 3 is greater than m, is greater than 2. So that's why we're gonna use the partial fraction in this situation. So how does it work? Basically, we're gonna use some constant. So for the first constant, we're gonna say it's a. So this constant is a. Taking the first bracket, so we'll say a over x minus 1. And then moving to the second bracket, so b over x plus 1. Note that between the two terms we're having plus, so the addition sign. However, here we had multiplication, but because this is how the partial fraction works, then we're gonna have c over x plus 3. So we're done with all brackets. But this is not the integration. This is just partial fraction. And we're using partial fraction to simplify the equation. After the partial fraction, we're gonna just integrate everything here. So because we're having plus between the terms, we can just separate the integration. So I can say the integration of a over x minus 1 plus integration of b over x plus 1 plus integration of c over x plus 3, and yeah, here we have dx, dx, and dx. So for the first integration, we will get a ln x minus 1 plus b ln x plus 1 plus c ln x plus 3 plus a constant, which I'm going to call it k, for example. Many of you may be wondering why we said ln x is the integration for this. Simply, you just have a constant and 1 or dx over term, which is a polynomial of degree 1. So this immediately will be ln of something, which is x. Just like having 1 over x. Integration of this is ln x. So you can just deal with this term as x and write it instead, sorry, here, x minus 1 instead of the x here. However, also you can just do it by the other methods that we just covered previously, but this is just a quick way and you need to get used to it as you're gonna use it a lot with more complicated problems. So now how can we find the constant a, b, and c? You can find these just by taking any value for x and substituting it. But how you're gonna do this? You're just gonna take the value for or the terms in the numerator, and I will say 7x squared minus 10x. Was it minus? No, plus minus 1 equals a, and a will be multiplied by the other brackets that are not in its term. So here I'm having a times x plus 1 times x plus 3. Just imagine as you're trying to add all terms and you need to have the same denominator for all terms. So here we're gonna have b over times x minus 1, and then x plus 3, and then c times x minus 1 times x plus 1. And then let's assume that I just choose to have x as 1. This term will be cancelled and this as well, so I will have only the value a with another value as well as this, and then I can just find the value of the constant. And also you can do the same for the other constants, just taking any values. And that's it for our video. Thanks for watching.